Hello, this is Mr. Bess. Welcome to Chapter 1 Functions. This will cover homework questions 4 through 8. Question 4. Angelica is working with function machines. She has two machines shown at right. She wants to put them in order so that the output of the first machine becomes the input of the second machine. She wants to use a beginning input of 6. So we know the beginning input, no matter which one we plug it into first, is going to be 6. Part A. In what order must she put the machines to get a final output of 5? So for example, if we wanted to start with the first machine and say x is equal to 6, then that would be y equals the square root of 6 minus 5. And then you just simplify this as you go along. That would be the square root of 1, which is 1. Now she says that she wants to make the output of the first machine become the input of the second. So now we're going to take this y equals 1 and then basically plug that in as x equals 1 into the second machine. So y is equal to 1 squared minus 6. And that would be 1 minus 6, which is y equals negative 5. So it would look like this. X equals 6. We get an output of y equals 1. Then that gets plugged back into the second machine and gives us an output of y equals negative 5. We're wanting a final output of 5. So it doesn't appear from our work that this one is going to work. So now we're just going to go back, make some changes, and say, all right, well now instead of plugging x equals 6 into the first one, we're going to plug it into the second one here. So now I'll just repeat what I did, but with the second machine first. So y is equal to, we'll now do 6 squared minus 6. That would be 36 minus 6, or 30. Once again, we'll take that and plug it back into the first machine as x equals 30. And so now we get y equals the square root of 30 minus 5. And that's the square root of 25. And the square root of 25 is 5. And that's what we're looking for, a final output. So here we go, just to show you the machines. X equals 6, we got an output of y equals 30. We then plug that into the first machine here as x equals 30. And got an output of y equals 5, which is what we're looking for. So in what order must she put the machine? The first one would be y equals x squared minus 6. And then the next one, y equals the square root of x minus 5. Always make sure you answer the question that is being asked. Don't just show the work, but answer the question that is being asked. Part B. Is it possible for her to find an input that will get a final output of negative 5? If so, show how she could do that. If not, explain why not. Well, this kind of works out nice because we did it the first and second machine that you can see over here. We already did that, and we got an output of negative 5. So we know it does work. It's just that you will have to reverse the order here and start with y equals the square root of 6 minus 5. So that's when x is equal to 6, and we get y equals 1. And then that goes back into the other machine, and we get y equals 1 squared minus 6, which we already did this, but just showing it again, is y equals negative 5. So there is your final output of negative 5. It says, if so, show how she could do that, and that is basically you're going to plug it into the first equation, or the first function, y equals the square root of x minus 5 when x is equal to 6. I'll write that down when x equals 6, and then that will get plugged into the second machine, y equals x squared minus 6. And so once again, making sure that you are explaining and answering each of these questions. Question 5. Evaluate each absolute value expression. Review the math notes box in the lesson for the definition of absolute value. So I suggest going back and looking at the math notes if you don't know the definition of an absolute value, and I'll go ahead and read it to you from the math notes. It says that absolute value can represent the distance on a number line between a number and 0. since a distance is always positive, the absolute value is always either a positive value or 0. The absolute value of a number is never negative. Once again, because we are talking about a distance. And so when you use absolute value, use the vertical bars that you can see. So in part A, it says the absolute value of 54. So really what that is asking is, how far is 54 away from 0? Well, 54 is 54 units away from 0. And that's your answer. No more absolute value bars. That's part of you answering the question. Now in part B, you'll notice that there is a negative sign or an opposite sign in front of the absolute value. So that's going to stay there. And then we're going to take the absolute value of negative 7 3/5. So how far is negative 7 3/5 from 0? It is positive 7 3/5. But the negative on the outside of the absolute value, or the opposite, stays there. So our final answer is negative 7 3/5. Part C, you have two absolute values. So the absolute value of 3 is 3. Then you have a minus, and then the absolute value of negative 1 is 1. So we're evaluating these two with the subtraction sign staying in between. So 3 minus 1 is 2. And then on D, because the absolute value is here and here, you have to do what's inside of it. It's a grouping symbol. So you need to take 2.2 minus 5.13 and then take the absolute value of that. So when you subtract those, you get negative 2.93, but you can still see the absolute value still there because I haven't taken the absolute value just yet. Now what's the absolute value of negative 2.93? That is a positive 2.93 because that's how far it is away from 0. That's the distance that you're talking about. So notice on all my answers, the absolute value bars are now gone because we have evaluated each of those. Question 6. Examine the tile pattern at the right. On your paper, sketch figures 4 and 5, and then we'll go from there. So I'm going to sketch figures 4 and 5 over here. So figure 4, and then we'll do 5. Now the first thing is I got to look at the pattern. What I notice, and you guys, everyone can notice kind of different things here. I notice we have a corner, and then there's 1 on each side. We have a corner, and now there's 2 on each side. We have a corner, and now there's 3 on each side. Or some of you will say, well, there's 4 here, and there's 4 here, but this one is actually getting repeated. So in figure 4, for me, the way I looked at it is there's a corner, and then now with figure 4, just like figure 1 had 1, 1, figure 2 had 2 and 2, figure 3 had 3 and 3, so for me, figure 4 will have another 1, 2, 3, 4, and then same thing here, 1, 2, 3, 4. Figure 5, same idea for me, corner piece, and then now I know there's going to be 1, 2, 3, 4, 5, and then another 5 here, 3, 4, 5. So make sure you sketch those out. Using graph paper makes it a little bit easier. On B, how does the pattern grow? Explain how you know. So now how does the pattern grow? Well, on figure 1, it looks like we have 3 tiles. On figure 2, we have 5. Figure 3, you have 7. And I'm just going through and counting how many there are. Figure 4 is now going to have 9. And figure 5, I have the 10 plus the 1 corner piece, which is 11. So how does the pattern grow? Well, the pattern grows by 2 tiles each time. And explain how you know that. Well, I know that because I just counted them up, and I can see that from 3 to 5 is, I'm adding 2. 5 to 7, I added another 2. 7 to 9, I added another 2. C says, how many tiles will there be in figure 0? The figure before figure 1. So now we're looking at, okay, what happens if we do have a figure 0? Based on the patterns that we have, I know that there will be only 1 tile because now we're going backwards by 2. What I was looking at is I still have that 1 corner piece, but I won't have any side pieces. So it looks like I'll just have 1 single box on figure 0. So how many tiles will there be? There will be 1, tile in figure 0. And so there we go. We've answered all 3 questions based on the tile pattern. Once again, make sure you are answering those completely. Question 7, simplify each expression. So we're just going to go through. There's a couple of these that we might have a little bit more questions on than others. As we go through, we're just going to talk about the different things that we should kind of recognize as we add and subtract, multiply, and maybe even do some exponents on this one. So negative 42 plus negative 17. Since they're both negatives and opposites, we're going to be adding in the negative direction, so we can add the 2 numbers up to get 59. But since they're both negative, it'll be a negative 59. So think about that on the number line. On B, it's 8 minus a negative 9. So 8 minus a negative is the same thing as 8 plus 9. So that will be 17. C is 8 times negative 9. A negative times a positive is a negative. So that would be negative 72. We have division here. Negative 42 divided by negative 7. Another way you could potentially see this is 42 divided by 7. Negative divided by negative is a positive, so that's positive 6. We have 3 numbers that we're multiplying. You cannot multiply 3 numbers together all at once in the snap of a finger. Like you can't, it's just impossible to do. So what you're really doing is multiplying 2 numbers together at a time. So for example, negative 2 times negative 3 is a positive 6. Positive 6 times negative 4 is a negative 24. You can't do all 3 of them together at the same time. Now you can do them in a different order. So you could potentially do the negative 3 and the negative 4, which would be positive 12. 12 times negative 2 is still negative 24. On F, we have negative 18 minus 7. They have the same sign, so they're both negative, similar to A, just written differently. So you just add the numbers up to get 25, and it will be negative 25 because you're going in the same negative direction. On G and H, I want to really look at these. G, the way this would be written out would be negative 5 times negative 5, because the base is negative 5 and you're multiplying by itself 2 times. So that would be a positive 25. The difference with H is this negative is not with the 5 that is being squared. Order of operations have you do exponents first. So really this would be negative and then 5 times 5. It's the 5 that's being squared. So what you end up getting is negative 25, not a positive. There's a huge difference between G and H that we need to work on. And then on I, the square root of 49, the question is, what squared gives you 49? And the answer to that is 7. Now, I know negative 7 squared is also 49, but when you're taking the square root of a number, you're only given what they call the principal root, which is the positive number. So 7 squared is 49. And question 8. For each equation below, find y if x equals 2. So it's giving you the x value, asking you to find the y value. So we're going to plug the value in, keep everything the same except replace the x with 2. So now we have y equals 7 minus the absolute value of 2, or 7 minus 2, which is 5. So y equals 5 when x is 2. B, y equals 2 squared minus 1. So 2 times 2 is 4. 4 minus 1 is 3. So when x is 2, y is 3. And on C, you have the square root of 2 plus 14. That's the square root of 16. What number times itself gives you 16, and that would be y equals 4. Once again, it's the square root of 16, so we just want the positive number for that, which is 4. So that is it for the first lesson of Chapter 1 on functions, homework questions 4 through 8.